again. Today I'm going to talk about one of the labs that you're going to do called the Moon Phases Lab. And in this lab, you're going to observe the moon um, on up to 14 nights, so over a 2-week span. Now, there are going to be two very specific windows of time that you can make these observations. And we'll talk a little bit more about why that is in just a moment. But this is listed as Lab 5 in the homework or in the schedule because it is not due until I think around April 1st. However, this will take you quite a bit of time to do. Like I said, you're going to make 14 observations of the moon over a 2-week span. And this requires the moon to actually be observable at that time, right? And we're going to talk more about that. But what you will do in this lab is every night you will go out and you will look at the moon sometime between 6 and 10 p.m. Now, sometimes the weather may not be cooperating. It may be cloudy. And you will list this if that is the case. But the goal is to try to observe the moon every night over this 2-week period. So let's talk about moon phases. Okay, so the lab that you're going to do looks like this. And there are only going to be 2 windows of time that you can complete this lab. One is going to be from February 17th to the 28th, right? So that's the end of this month. And then also you can complete this lab March 17th through March 28th. Right? So between 6 p.m. and 10 p.m. each night, you're going to go out and you're going to observe the moon. So in astronomy, whenever we do an observation, there's some very important information that we have to log with every observation, right? So the date and the time that you are making the observation, the location of your observation. Now, this can be the city that you are in or the town, but ideally, you want to be a little bit more specific in that, right? So if you're in Bowling Green and you're observing from your house, you need to put Bowling Green house. If you're in Bowling Green and you're on campus, you can put on campus. Because the quality of astronomical observations are going to depend on the location you're at, how much light pollution there is at that site. And so if you were keeping a real observing journal, you would want to list things like this. Also, the approximate air temperature. This is going to affect scene conditions quite a bit. And the cloud coverage and weather conditions. Now, cloud coverage, you can say partly cloudy, mostly clear, or if you want to be really specific, and you can list approximately the percentage of sky that is covered by clouds, right? And then in this area, you're going to shade what the moon looks like, right? Now, what would be even better than shading what the moon looks like is taking a picture with your phone of what the moon looks like, right? I will warn you that if you try to fake these observations, I will know and I will not give you credit, right? So make sure you actually go out and do the observations. And so there's time slots for 14 different days, right? You should try to observe the moon on each of these days in the observation windows. This may be a little short. You may be able to observe either the day before or the day after this, right, to get another observation or two in. But let's talk about why. This is the window that you can observe the moon at these times. I've also posted some important events that are coming up in the world of astronomy. So on February 18th, which is one day into the first observation window, if you make an observation that night, you will see the planet Mars, very close to the moon, right? This doesn't happen extremely frequently, and it's a very nice thing to see, right? So if you do your observation that night, then you'll be able to see Mars close by the moon. And I also put in 5 bonus points if you include a picture of this event with your moon phases lab, right? So you can just take a picture with your phone. You might have to zoom in a little bit to make sure Mars is visible in there, but I want to cover a little bit about moon phases. So the moon phase cycle that we see here on Earth is 29 and a half days, meaning that it takes 29 and a half days to go from one new moon to the next, right? To go through a complete lunar cycle. This is not the same, however, as the lunar orbital period. So the time it takes the Earth or the moon to go around the Earth. That is only 27.3 days. However, during that time, the Earth has traveled in its orbit around the sun. So essentially, the moon phase, this is the difference is the time it takes the moon to kind of catch up, right? So the phase that we see the moon depends on the moon's position relative to us and to the sun, right? So, for instance, when the moon is between us and the sun, this is what we call the new moon phase, right? So, imagine that we are here on the Earth, and as the Earth faces toward the sun, right, we are in daylight. The new moon is visible during the daytime. In fact, it rises approximately sunrise, and the moon sets at approximately sunset. So the moon is visually close to the sun as we see it during the new moon, right? So as the moon makes its orbit around the Earth and we are rotating on our axis, right? We start to see the moon illuminated more and more each day, right? So when the moon is going from new up to the first, or up to the full moon, actually, we call this a waxing moon, meaning that the part that is illuminated with respect to us is getting bigger, right? The moon is or the part of the moon that is illuminating is getting more. So at about 1/4 of the lunar phase cycle, we have what is called the first quarter moon, right? Because it marks the first quarter of the lunar cycle. Right? And this occurs about a week after the new moon. Okay? As the cycle continues, the moon continues to increase the illumination, that the illuminated part that we can see, until the moon is directly opposite Earth with respect to the sun. So we have the sunlight coming from the left there, and then the moon is on the other side of Earth, which means that we are going to see what we call a full moon, right? So all of the side of the moon facing us is illuminated. This occurs about 2 weeks after the new moon, so about 14 days. And during the full moon rises at roughly sunset and sets in the west at about sunrise. So the moon is visible the full night during this time. And then as we progress further in the lunar cycle, then the amount of illuminated portion of the moon that we see decreases, right? This is what is called a waning moon. And when it's between 100 and 50% decreasing, this is what we call a waning gibbous moon. And then at roughly 3 weeks and 1 day, we have what is called the third quarter moon, right? So we can now see the other half of the moon illuminated. In the first quarter moon, remember we saw the right side of the moon illuminated. Now we're seeing the left side of the moon only illuminated. And the percent of the moon that we can see illuminated will decrease each day as the sun travels back around to line up between us and the sun. So currently, let's look at something else here. Just a moment. So as I'm recording this, today is the 10th. Tomorrow, the 11th, will be the new moon, right? So this means that the moon is not visible at night, right? Because the moon, remember, the new moon rises at sunrise and sets at sunset. So the moon we can only see during the day. And during a new moon, you cannot see it very well, usually because it is too close to the sun. But during the new moon, the side of the moon illuminating us, that is facing us, is not illuminated by sunlight, right? It's actually illuminated by the light from the sun reflecting back from Earth onto the moon, okay? So during this time, this is what it's called earth shine. But to us, you know, it's going to appear dark compared to what were the other phases, right? Where we're getting direct sunlight from the sun illuminating a portion of the moon. Let me get back to the calendar, right? So starting here on or about the 17th, the moon will be visible in the sky between 6 and 10 p.m., right? From then until about the 28th, right? So on the 28th, between the moon, I'm sorry, the 27th, the moon will rise at about sunset and then set at dawn. So the moon rises typically about an hour earlier each night. So your first observation window will be next week and the last week of February. Now, if you miss this observation window or you don't get all of your observations in for whatever reason, you will have another window of time that you can observe the moon between 6 and 10 p.m. at the end of March. So March is going to follow roughly the same time scale, right? So you're going to be able to observe roughly between March 17th and March 29th, between those hours. Okay. So I implore you, do not put off this lab. If you wait till March 30th and then you're like, oh no, I didn't do that lab, it's too late, right? All right. Until next time.